Hello, we, Saulis Rudys, Andris Lucys, Martynas Butkus, Šarūnas Budrevičius, would like to present our idea titled GNSS and SATCOM for Multipurpose Lightweight UAV with Radar. We're representing Vilnius University and Small Enterprise, Žvelk aukščiau or Up and Above. As you see from the title, our idea concerns radars. Radars are very useful. We can see in the dark, through the fog and clouds. Even more applications we can implement if we use radar on a UAV. Example of such applications can be authentication of vessels when identification by AIS system fails, anti-piracy and anti-drone system, ice monitoring. But radars usually are heavy, big and expensive. So airborne radars usually arranged in heavy UAV. Obviously, operation costs of big UAV will be high. In order to solve these problems, we suggest to integrate antenna into the wing as presented in the picture and video. So we're significantly reducing weight and air drag because we are eliminating radome and rotator. In this case, scanning is done by changing heading of aircraft. Evolution of our idea is presented in bottom line, from the drone with simple marine radar to fixed wing UV with integrated radar antenna. Moreover, we can implement 3D scanning. How does it work? We're using fan beam. This beam is narrow in horizontal plane and wide in vertical plane. During the flight with curved trajectory clockwise and counterclockwise, radar response will be slightly different as presented in radar display 4. It is right in the case when altitude of a target differs from UAV altitude. The higher is the target, the bigger is distance between responses 5 on the screen. Value of altitude can be calculated from this difference. Our solution provides long list of benefits for a user, as wide area of applications as we mentioned before, possibility of launching from the vessel, it is important for anti-piracy applications, as well as higher operational range. Naturally, the lighter is equipment, the heavier can be the fuel tank. Loose legal requirements, obviously the smaller is UAV, the looser are requirements of civil aviation authorities. Low price of equipment, because we're using mass production marine radars, low operational costs due to smaller UAV, and possibility of 3D scanning, what we speak about in previous slide. It is important in anti-drone application when we're using UAV as a drone hunter. What are the differences from existing solutions? At first, set of benefits what we already mentioned. But also, for example, in the picture, we can see heavy UAV bringing shorter antenna than our small UAV. Angular resolution of the radar depends on antenna length. It is fundamental law. So our radar will have better resolution than one in heavy UAV. Second, our solution can provide unique possibility of 3D scanning by simple equipment. How about GNSS? It is obvious that UAV and AIS exploits GNSS. When application concerns security of borders, risks of jamming and spoofing are very plausible. Galileo system is preferable because it is more robust against jamming. Since spoofing is plausible, spoofing-proof Galileo PRS should be used by authorities. Since we accomplish radar scanning by the attitude of UAV, it is important to know the pointing direction of the radar. We're using 2 GNSS receivers with 2 antennas at the tips of the wings for calculation of the direction. Inertial and magnetic sensor are auxiliary. Our idea is being applied to SATCOM challenge because at long ranges behind sight of view we will lose control and data of UAV. Most of applications suppose long range of operation. Since radar scan is relatively slow, we don't need high data rates and small lag for radar imaging in real time. But for anti-drone missions, higher data rates and lower latencies are necessary. And for the business case, we're focused on a wide range of applications. We already covered possible applications before. The wider our applications, the smaller our risks, and the bigger is the probability of successful business. Customers for various applications can come from both public and private sectors. The main foreseen institutions interested in the project should be interested in sea vessels monitoring, which is a simpler task or drone activity monitoring. Preliminary agreement was met with local border control service regarding sea border monitoring. Similarly, the greatest demand for technology is expected from seashore countries performing vessel monitoring. The project is a joint venture between Vilnius University, as representative of academia, and UAB Žvelk Aukščiau as the small enterprise. The financing for the initial phase of development as a side product is already secured from EU funds. UAB Žvelk Aukščiau, being manufacturer of the UAV, invests its own resources into the project. Considering the possible competitors, radars are normally installed into manned vehicles or large UAVs, which are considerably more expensive, therefore cannot be considered as direct competitors. Radars with comparable parameters are produced by IMSAR company. Nonetheless, those rely on synthetic aperture radar technologies and due to incomparable principles of functioning cannot impose direct competition. The time frame for the project, in case of sufficient funding, could be in range of 1 to 1.5 years. Legal aspects is an important part of the project. They can increase or decrease commercial success of the project. Concerning IPR, PCT patent application has been made. IPR belongs to Vilnius University, and if IPR will be necessary, we made preliminary agreement with IPR owner Vilnius University. Some members of a team are inventors, and our idea concerns UAV. Application of UAV is under regulation by aviation authorities. Positive thing is that the weight of our UAV is only 10 to 20 kilograms. The lighter UAV, the more flexible our requirements. The idea has been developed in joint collaboration of academia, Vilnius University, and business, SME Žvelk Aukščiau, during which 2 prototypes, rotorcraft and fixed wing, have been manufactured, therefore reaching technical readiness level 5 to 6. UAB Žvelk Aukščiau, being the manufacturer of the UAV, invests own resources, human resources, materials, and know-how. Most of the IPR regarding radar technology belongs to the university. As was mentioned, the initial phase of the research is financed by already secured EU funds. The next steps for development plans are publishing the scientific paper on the research, working on the commercialization and financing of the enterprise, the first commercialization planned with National Maritime Border Control, where preliminary agreement was already reached, and the second planned commercialization step is an anti-drone application of the technology. Thank you very much for watching through our presentation, and if you have any questions, please let us know.